So today I'm just going to step over this next library. I have no idea what it does, and I didn't research anything about it. And I didn't even check to see if the debugger is working. So if it fails, I'm just gonna try another one. I think probably I'm going to. I said that I was gonna do this last time, but I didn't do it yet. It's probably here, like on the main thing. I'm just gonna do notes. Then I will think about maybe questions is better. Probably notes. I'll leave it like notes for now, and then I'll think about it later. But I have to write down this stuff. So I think that procedural. Maybe I'll do it based on library. So I didn't understand how the macro worked. Had an error because I was trying to use command instead of command. True. There are so commands inside of the struct. So the question is, how can I know what's syntax maybe? Words? Maybe syntax is better. I can use whenever library uses procedural macros. I'll think about this, like a different way to do this, maybe later. But I think probably the best thing to do, because I don't want to spend a bunch of time doing this stuff off string. And I think that if I start like studying with the LLM off string, and asking questions and trying to clarify like the exact way, the best way possible to create a training, I'm just gonna deviate too much from the rest of the things I'm doing upstream. So for that reason, I think it's probably better to try to keep like as low effort as possible and then accumulate over time. Like I review all the libraries, then I focus to see like what are the parts that I'm not really sure about each one. The ones that are most curious about, then I write notes based on that. Then once I have all the notes, then I go over with GPT or another LLM, and I try to clarify each one. Then maybe brainstorm like a way to study them effectively, and then from that point brainstorm how to create the exercises. And so this is another question I have right away here, which is I kind of get it, but I don't at the same time. Because these are generics here. So it's mixing a generic type with a lifetime. And the thing that it's kind of difficult to understand, but I guess I kind of get it, is like how does it work from the compiler's point of view? How does it parse whatever is inside of the brackets here? How does that affect? Because I think that the order probably doesn't have an effect. So the way that I read this now is that you have this is like a structure that creates an intersection between generic types. So the generic types could be any type, but the combination of them has to follow the constraints of the implementation of the of this implementation or of this struct or whatever that you're using the generics for. I guess the question is more like how do you think about this? Because the hard part for me is thinking about like how when I'm gonna use something like this, how can I think about what types, how I'm gonna initialize this, what types I'm gonna use for C and F, and what are the consequences of that on the rest of the program. I'm not really sure how to put this into words. I think that the reason why it makes it very hard is because what if you have like a massive implementation? And here they have the constraints. So the where limits the amount of types you can use. So whatever type you're gonna use, allow it has to allow the same behavior as this type here. And this becomes more complicated. Like this, I think is one of the main things I'm trying to improve, but it's very hard to think about because it's not really hard to read. I guess it is kind of hard to read because you have to understand like how the generics is going to impact the overall flow of the data. But it's even harder to think about how to implement this yourself. Because I think that the first instinct that I'm going to have is probably not going to be to write types with all of these different generics. So I guess the question is under what kind of circumstances are generics favored? And I think that this is probably on situations where you have a lot of volatility or on boundaries. So for example, JSON parsing is a very common thing where you're gonna have these generic types because you don't know what kind of data you're getting, I think. Like the boundary between the JSON and the language. But I'm not really sure. And maybe this like whenever you're building a library or something like this. This is another very common thing that I already like is already on my mind, but I'm not really sure how hard it's gonna be. Maybe I'll write down here like general or something. How is the best way to investigate this thing kind of macros show up quite like this stuff here because it adds a bunch of code and then you have no idea what's going on actually, so it's very annoying. And I think this is the part of the standard library probably based on the path here, and it is the fn once is the type for a function that is called only once, as the name implies. This is gonna be the type of the output. But then why does it go there? I don't understand. Yeah, this is another question. Maybe because of this. But this is a generic. So I'm gonna ask this as well. So obviously, maybe not obviously, but I assume that F is for future here, or something like this, because it has this send and sync. I think that send and sync is something related to future, because future is related to async programming on Rust. But obviously, I'm not 100% sure about this. Oh, maybe it's because I think it's because of this. So here is going to be based on this type. Yeah, so maybe this is another question. Because here you have implementation, implementation has this type, but then it's passing another type. Is initializing this with another type. So how is the compiler gonna know how to translate one from the other? What is the derivation that it does? And obviously that should it's probably gonna explain why does it go to the F output there. Maybe it's because I don't understand how this works, but I assume here is saying that this is gonna be the union of send and size. I have no idea how it works though. So when I press F12, here it goes here. There's a name for this kind of types that they define here that I forgot. I think it's associative type or something like this. It is kind of a generic type. I've seen this on iterators, I think, or some other places, and it's just like on the implementation that I remember, this item is supposed to be whatever the thing you're gonna traverse over, like the unit of a vector, for example. And I think I saw on this intro iterator. So here it is a type, associative type, I think. But it still doesn't like clarify the questions I have about this, because then why is it going? It's because of Sam doesn't have anything. So another thing is that I wanna clarify is when I press F12 to go to definition and get into a trait, how do I know what implementation of that trait should be looking into, or to understand how the original thing that's used traits works? It's very confusing for me because I'm very used to looking to the definition inside, and obviously you can assume based on the type that it's just going to translate one thing into the other, and that's kind of all you need to know, but it's still kind of not very good for me. So far, based on what I'm seeing, it looks like it is a library to optimize iterations over things, probably. Also here it has types on. whatever. And for example, this is a perfect example of what I was talking about. From the previous time that I was going over clap, that I talked to ChatGPT, whenever you return this self here, it's just going to return the type that call this function. But then, like, it doesn't allow you, just looking at the declaration here doesn't allow you to understand anything about what actually happens. But I guess it's going to be whatever, based on the name, you can assume, but obviously I think that's going to do something like inside of the whatever thing implements the trait. Then based on the comments, you can also know, but like not looking at you into the semantics of the language directly. It's kind of annoying. Okay, so as it's saying here, it's gonna connect the producer with the consumer. Then it's gonna take items from the producer and feed to the consumer. Splitting and creating parallel tasks when needed. What? Press F10 to go faster. So this might be a problem with the debugger, or might be a problem with the implementation, but I think it's more likely that it is a problem with the debugger for some reason. I'm gonna try to press, if I press F5, it just got stuck there. I'll try to compile this, or to run from the terminal. It's easier to just press play there to see the main again, and just go there. So it does run. So I think that is probably an issue with the debugger. So I'm just gonna go with F12 here. And because the way that it is, like maybe one thing that I can do is just like do this and then try to compile and see the messages here. Let me, not sure if this works. How does it work? So obviously I don't understand how this works. So I think that my guess would be that Rust has a built-in iterator type that is used for iterating on things. So for example, if you declare a vector and you don't have anything, like you're not using any libraries, and then you loop over the vector, under the hood, what I assume Rust is going to do is going to use that iter implementation to determine how to move in the memory based on the type of vector you have. And that's what happens. And I think what this is doing is implementing something that changes that behavior, probably. And that's how you can use here without explicitly using anything there. And this one doesn't have much. Maybe if I try to also put this one there. Okay, now it works. Let's see if that's what is going on. This conversion to a parallel is a parallel version of the iter methods defined by various collections. Yeah, I think that it is exactly what I was talking about. The implements. Alright. What I don't understand is how is it possible that this override somehow overrides the default behavior. That's what is confusing to me. Because there's not is not doing anything explicitly here. Just use the vector, but then it goes here. Why? Not sure what's the best way to. Maybe it's because of this. I forgot the name of this. I'm gonna ask. I'm gonna see if I can find on Google or. What is the name? The time. It is declared. I don't know. Associated type. Maybe I can turn the questions into quizzes. That might be a good idea. So turn them into quizzes on that website. That's like another kind of training. I think that's probably a good idea. The thing is, like, this is not the type of thing I had in mind when I started this. Because I wanna more like do something like as a ritual, so I can kind of memorize the patterns, but without necessarily memorizing. I think there's just gonna be the same implementations. Maybe maybe I'll stop here. Maybe I'll move on. Again, like I feel inclined to stop streaming and then just ask GPT, but then like I'm gonna deviate too much. I'm not really sure if I should. You should probably just left like this or leave like this and then just accumulate a bunch of questions. Just do short streams until I go over all the libraries. Then I do one stream where I explore all the questions. Like the thing here is, I guess this helps understand the library, but I'm not really sure if I'm gonna use this one specifically. So maybe like for this kinds, I think 30 is gonna be better because I know I'm gonna use probably most likely. I already use 30 on some projects, and it's basically to parse JSON, maybe some other stuff. For this one, I'm not really sure, but as I can see here is obviously some optimization to iterate over things, which I can see that you would be very useful. But I'm just not sure whether or not I'm gonna use this. So since the other ones use this library probably based on the report, I think there is a decent chance I'm gonna use this as well. But what I'm trying to think about here is more like I don't think that it helps understand the stuff about generics there. And I think that this is like an issue that I'm gonna hit on all the libraries as well. Is the main thing that is annoying me the most is this thing about the trait. When you go to the definition and you have the trait, and then you don't know like how does it work. But I guess if I go on the actual usage, then I can see the definition. Maybe I should try to go always into the thing that is using or calling functions. But then this is an issue. Now is using the trait. I'm not really sure if I understand how this works. Okay, so it implements this for this. This is a trait, and no, I think this is the trait and is implementing a struct. Oh, another trait. This is very confusing. If this is a trait, is this? Is implementing a trait for another trait. And this is very confusing. The way that I think about a trait is like an abstract class on other programming languages. So there's a template of functions to determine how other things that implemented will behave. This is wrong. I guess like oh, it is implementing the trait for the trait. It just combines them both when you do like this. So whenever someone is using this function here from this trait, it's just gonna relate to the other one. I think that's how it works, probably. It's extremely confusing. And then here is the same issue again, where I'm not really sure how. I think that you can have multiple different implementations of the same thing. So how does that work? How do I find the function that is actually being used here? If I go into this, because I know that it's gonna return the item from the other trait. It's gonna map overlap, but then like there is like some uncertainty, I think. And because the thing, like, I'm not gonna be able to like clarify this just looking at the code. I need to clarify more the dynamics of the language itself to understand how can I find where this is actually defined. Because like this doesn't allow me to understand how does this improve the iteration. I think like that's the whole point of the library, it seems. Maybe I can compare if I don't have the. Maybe I can't even do this, even call this function a normal vector if I don't have the libraries here. But I think I can map over the vector. I guess the main difference would be the type that returns this type here, but then maybe if I see, because there's no way to know the definition of the other one unless I search for the whole library, which is gonna be very annoying. And this is like, I think this is the biggest problem in Rust that I encounter so far when learning other libraries. Very annoying. Here, go back. I think I'm just gonna stop here and I'm going to do some quizzes. I'm gonna go over fast on the libraries. But maybe it's probably worth to, like, next time that I stream, I'm going to go over the questions, I think. The notes that I have there, I think it's probably better. Because I know this is something that I'm gonna encounter on every single library that I go over. Maybe I do 30 first, because I know 30 is gonna be useful. Or it's gonna be interesting because I know that's already used on other projects. And maybe the other three here, I think this CPAL is for audio, audio related or something like this. And then Kendo is for neural networks. So I think the next three are probably interesting. It's worth to go over them fast, then write down questions. But I already know that I'm going to encounter the same kinds of issues. This one is very annoying. It has something to do with the bar brackets and the color bases and the parentheses. So I think that when it is a function, it's gonna print 1. If I understand this correctly. It's calling this. So this is a lambda function, I think, in Rust. It's calling this first, and it's gonna like return this expression. So the question is whether or not this is a function. But I think it probably is not. It's gonna return true. I think it's gonna return true here. Then this one, I think, is basically the same thing, probably. This is weird because I'm not. So maybe I think that loop is a built-in thing on Rust. You can do here. And it's probably gonna have like the methods. Can't. I can't go to the definition there. Press F12, it just goes here. Maybe if I do like this, yeah. F there. Hmm. Let me just copy this. Or maybe it's because it's implementing. So that gives the ability to call the. Yeah, so yeah, it gives the F function here. That's why. But it's still kind of weird because I'm not really sure what X is in this context. Sure, like if the loop is a function. I guess it has to be this one. But it's like pure guess. I'm just gonna guess true because I have no idea. So this one is returning a function. I think this one is gonna be 1. I'm gonna call the function. I think this one is gonna be 1. That's probably true again here. I think that this is gonna be true again because it's gonna be R. Not a function, it's just an R statement. And then same thing for the other one. Yes. Everything wrong there. Actually, the last 3 are wrong. The rest is correct. I think it runs the loop when you assign. It runs the loop and then returns the break. It returns the expression inside of the thing, which is the one, I think. I'm pretty sure that this is one here, is the first one. So I think I was reading that wrong. So it runs the loop here, then it runs the loop and then breaks right away, and then returns this. So X is going to be this function here, and that's why it returns one. Yeah, I think it was true. The first two were true, and the rest were one. So these ones I got it right. And so here again I made the same mistake. I didn't understand that it's gonna break. It's gonna run the loop and it's gonna break and it's gonna return this. But then this one is interesting of why doesn't it go. Maybe this is a one. Don't remember anymore. Maybe this, yeah. The first true or true. Let me just read the explanation again. This is a true. I mean, it's gonna call this one. Let's see. It breaks and returns this. So when it calls f here, yeah, for me it makes more sense that it would call this one because it's a function. So, well, it's because of the parentheses. So it just breaks out of the loop here and it doesn't care about this, I think. Yeah. So that's the trick. It's not going it doesn't return the function from the loop. It just returns an empty because of the curly braces, I think. Or the parentheses. So I'm gonna stop streaming here. Next time we're just gonna go over insert it and then probably gonna go over pretty fast as well on all the libraries that I review. I'm just gonna write a bunch of notes, I think. And once I go over a bunch of libraries and I have a bunch of notes, I'm gonna spend time going over them with GPT and then trying to formulate a plan to clarify everything, probably build quizzes around the stuff that I write here as well, and then trying to figure out how to create exercises that allow me to test this frequently or to improve at the stuff, at implementing the stuff myself frequently. So see you next time.